Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question C3 on our 2011 open paper. Let n be a positive integer. A row of n plus 1 squares is written from left to right, numbered 0, 1, 2, 3, all the way up to n as shown. Okay. Two frogs named Alphonse and Beryl, standard math names, begin a race starting at square 0. Okay, so A and B are both here. For each second that passes, Alphonse and Beryl make a jump to the right according to the following rules. If there are at least 8 squares to the right of Alphonse, Alphonse will jump 8 squares to the right. Otherwise, Alphonse jumps 1 square to the right. So either he does 8, so he'll do big hops of 8, and then when there's not enough space to do another 8th hop, then it looks like he'll just do single hops to the end. So at most he can do 7 single hops. Alright, and how does Beryl jump? If there are at least 7 squares to the right of Beryl, then Beryl jumps 7 squares to the right. Otherwise, Beryl jumps 1 square to the right. So same rule, except Beryl can't do as big a hop. And so at the end, she'll be just doing single hops, if any, and at most she'll be doing 6, because if she could do 7 consecutive hops, then she could have just done 1 big hop. Okay, let AN and BN respectively denote the number of seconds for Alphonse and Beryl to reach square N. So they hop once a second. So really we just need to count the number of hops. For example, A of 40, so if there are 41 squares, so 0 through 40, then we'll get 5. If it's for Alphonse, it'll take Alphonse 5. If N is 40, it takes Beryl 10 seconds, so 10 hops for Beryl. Okay. So, what are we being asked for? A part, determine an integer n greater than 200 for which b of n is less than a of n. And B part, determine the largest integer n for which bn is less than or equal to an. So I feel like these two questions are very, very related, as you would expect for a big written question with a sort of interesting concept, frogs hopping. So I think probably the first thing to do is try and get a formula for an and bn if we can. Now maybe we can't, but it seems to me that Alphonse, I'm just going to abbreviate that with A, will make as many 8 square hops as possible. How many is that? Well, that's n over 8, except n might not be a multiple of 8, so we're going to round down. This is the floor function, if you haven't seen it before. It basically just means divide these and round down to the nearest integer. So the greatest integer less than or equal to n over 8. So the remaining squares, he hops 1 at a time. So how many squares remain? Well, it's going to be the remainder when you divide n by 8. And is there a way to get that? Yes, there is. N minus... So what is this doing? Well, this is dividing by 8 and rounding down to an integer, then multiplying by that by 8 again. This is the nearest multiple of 8 to n without going over. Okay? So, in theory, an should be n over 8 plus n minus 8 over n over 8. But that can be simplified to minus 7 n over 8. So let me just check to see if that's true or if there's something wrong with my reasoning, because maybe I'm miscounting the right first step or something like that. because they start at 0. So what would it be for 40? Well, it would be 40 minus 7 times 40 over 8. So that'd be 40 minus, you don't have to round down there, it's 7 times 5. 40 minus 35, a 40 should be 5. Is that the case? Yes, it is. And we don't have to write down the reasoning again. We could say by similar reasoning. Bn, it's going to be the same thing except 7 steps. So we'll have n minus 6 over n over 7. Why? Well, let's just very quickly go through the reasoning again. Barrel would do 7 squares as much as possible, so you'd want n over 7, not 8. And then hop the remaining squares one at a time, and you'd be doing 7 over n over 7. And so one of those, and then 7 of these would cancel out, and there'd be only 6 of them. Okay, so that's the reasoning there. And let's just, again, double check. So that'd be 40 minus 6. 40 over 7. Now this time there will be some rounding down. 40 over 7 is about 5 point something. Because the nearest multiple of 7 is 35. So we'll have 40 minus 6 times 5. That's 40 minus 30. And that is 10. And 10 is what we had. So I'm confident in our formulas. Okay, now we want integers, one integer greater than 200 for which bn is less than an, and then we want the largest integer n for which bn is at least less than or equal to n. So really what we're talking about is this relationship. Okay. One with the less than sign, one with the less than or equal sign. I think B part is going to be harder, but so I'm going to focus on that one. But I think most of my work will be fine, and I can just switch through between a less than or equal sign as I will. But okay, so there's Bn, and there's an. Now we can subtract n from both sides, multiply by a negative sign, and then we can get 7 over n by 8 is less than or equal to 6 over n by 7. Okay, so that needs to hold, and similarly, Bn is less than An if 7n over 8 less than 6 n over 7. Okay? The inequality, the equal sign is not really helping a whole lot. The inequality is not really changing a whole lot. It's just the sign. Okay, so we should probably experiment with this sort of a thing. Now, I don't like the floor function, and if you've been experimenting with it in the past, you know you probably don't like it. It's not the nicest thing to manipulate when it comes to formulas and equations and things like that. So, in an effort to get rid of this n over 8 floor function and n over 7 floor function, I think might be a good idea to look at n as a multiple of 56. So, for example, if it was just a multiple of 56, then we'd have 7 56k over 8 needs to be less than or equal to 6 56k over 7, but of course this can be simplified to 7 times 7k less than 6 times 8k. Okay, so that can never hold. So this isn't going to work for multiples of 56, but I was hoping that would just be a quick, short example of the and I guess it sort of was a quick, short example of how the simplification can happen, but I guess we'll probably need plus some remainder r. And then for certain ranges of what r can be, you're going to get certain n over 7s and certain n over 8s. I suppose we might just want to make a chart for this sort of a thing. So based on R, if R is between 0 and 6, then n over 7 floor function is going to be 0, and n over 8. I think I should probably just make 2 charts, because it's going to be hard to keep track of all the r's and everything like that. So I'll get a range of values for r, anything from 0 to 6, and n over 7 floor function is 0. Well, not 0, it's going to be 8k. Anything from 7 to 13, the r will introduce a plus 1 here, so we'll get 8k plus 1. Anything from 14, it'll go up by multiples of 7 all the way up to 56. So 28, 35, 42, 49 to 55, at which point we tick over to another value. We turn over into 8k. No, 8k plus 1, sorry. Let's see here. 35. It's just the number before it, right? And that'll be 8k plus 2, 8k plus 3, 8k plus 4, 8k plus 5, 8k plus 6. I feel like things are not lined up proper. And then 8k plus 7. Yeah. Similarly, we can make another chart, but from 0 to 7. And now we're talking about dividing by n over 8, and you'll get 7k. And then 7k plus 1, and 7k plus 2, and 7k plus 3, and 7k plus 4, 7k plus 5, 7k plus 6. And so this will go up by 8, 16, 24, 32, 40. And 48 through to 55. Okay, so these range of values will give different r's. Okay. And so all of these ones over here look like an 8k plus a. All of these look like 7k plus b, and I feel like there's going to be sort of a relationship between a and b and something like that. Okay, so what did we even have a while ago? 7 n over 8 less than or equal to 6 n over 7, and this is going to be 7 times 7k plus b is less than or equal to 6, 8k plus a. We'll get 49k plus 7b, 48k plus 6a, and we can subtract a k from both sides. And here now we can limit k. And the limiting of k sort of puts a limit on how big n can get, which is what they're getting at in this question. They want the largest n. So what's the largest k can be? Well, in theory, I suppose we could say the largest k can be is when b is as big as possible, so 6, and a is as small as possible, so 0. But I suspect this won't be exact, because then you'd say k could be at most 42, and I don't think that. I think because a and b are sort of stuck together. They're stuck in a little bit of a relationship. A grows a little faster than B. B is always A, or I think A plus 1. Or, sorry, A minus 1. A or A minus 1. I think. I don't know, let's pick a random one. So 33 would get me 4. B is a 4. 33 would get me A is a 4. But 35 would get me A is a 5. And we'd still have B as a 4. So I think this is true. This relationship is true. If it, I'll double check it, and of course I should justify it. This is a Part C question, but just moving ahead, then this means that we've either got 7A minus 6A, which is A, in which case K is at most 7, or we're looking at 7A minus 1 minus 6A, which is going to be A minus 7, and that's not so good. So I feel like K is at most 7. Well, hold on a second. We can do all this same work with the less than sign. And so if I want, if I just want to answer A, and so if we're stuck on B, we should at least answer A, because I feel like it's the easier one. If we're looking for something greater than 200, then we should have, so if N is about 56K, then we're looking for a K that's about 4. So can I make K 4? Sure, we can make a K4, and then I just need to pick a B and an A that works. So maybe B is 4, A is 4. That would give me a difference of 28 minus 24. Oh no, I guess it should be 5. Because otherwise K is not less than, is less than or equal. So, let's say something like let K equal 4. And can I find an R so that A and B is 5? So we need to be, if we want 5, we need to be in this range. And if we want 5, we need to be in this range. Is there an overlap? Yes, there is. 40 or 41 will do the trick. So let R equal 41. Then A is 5 and B is 5. So N is 56K plus 41. And that'll be 56 times 4, 4 and a 2. And then we add on a 41. So 5, 6, and a 2. Is it AN less than BN that we wanted? No, it's BN less than AN. That's fine. If we wanted to, I suppose we could double check this. 2, 6, 5, might as well, because I'm just trying to, in the back of my head, think of ways to finish things off with this question. Remainder 5, 5, 5. 7 and a 55 gives me 7 with a 49, so a remainder of 6. So 37 plus 6 is 43. And so that's my BN. And then 8 into 2, 65. 24, bring down the 2. 24 and a 1. So something seems off. Did I set the equation up wrong at the start? No, BN less than AN. Get a remainder of 1, but then AN should be 34, and that's not less than 43. So what did I screw up? We definitely get A and B being 5. I'm sure there's just an arithmetic mistake somewhere that I've made. There it is. 7B's on the wrong side. 6A minus 7B. Okay. There we go. So it wasn't too bad. And now we're going to need... I miss my old notes where I could just click a page and have it clear. Unfortunately, people are constantly updating their software. I suppose I could have just put a big red X through that page, but... Alright, so there we go. Slightly different tweak to things. So I just made a little mistake. I'm sure somebody was already typing in the comments about that. My mistake. So, B is always less than or equal to A. Now, if A and B are equal, we're going to have a bit of a problem there. But, there we go, we can fix that. What can we have? So, is B really A or A minus 1? Yeah, it should be, but, okay. So, again, if I want K is 4, 6A minus 7A minus 1 is going to be equal to 7 minus A. So I need A to be at least 2. Sorry, at most 2. Okay, now that's doable. So we could say something like, let K be 4, and then I need both of them to be 2. So we're looking at this range. And this range, something like 20 will do just fine. So 56 times 4. I did just work this out. I think it was 224 plus 20, 244. All right. I'm glad I did double check that. I wasn't actually planning on doing that. But so n equal to 244 should have... gives AN less than BN. So once again, let's just very quickly, 244, divide through by 7, you'll get a 3 there, 21, 34, and 4 of those go into 34, so 28, remainder is 6. So BN should be 40, AN should be less than. It is AN that I want less than. I can never remember. No, it's BN that we want less than. Okay, so should probably correct that then. So we're hoping for something bigger than 40. So we get a 30. With a remainder of 4. Darn it. So what's going wrong? Oh! Silly me, I needed A less than 2, and B needed to be A minus 1. That's where I goofed. Alright, let's do this again. So the B needs to be minus 1, so we're actually up here. So something like 15 will do the trick. So we add 15 to 39, and we redo our remainders, and we still have a B part to do. I think maybe I'm just trying to do it too quickly. So a 3, a 21, carry 2, down 9, 4, plus a remainder of 1. 2, 16, 7, and a 9. So we should get 9, and so that's a 72 with a remainder of 7. And so that's 36, and this is 35. Hooray! So not 244, but 239 should do the trick. Okay. On to B part. If I want Bn less than or equal to An, then I need K to be less than or equal to 6A minus 7B. Okay. B is either A or A minus 1. Let's briefly explain why. It's just going to be a rough argument, but B goes from 0 to 7. A goes from 0 up to 8. Actually, might be easier to explain it like this. B is n over 8, which is automatically less than or equal to n over 7, which is not n, r. Okay? So that's true. If B were somehow less than or equal to A minus 2, then R over 8 would be less than or equal to A minus 2, which is R over 7 minus 2, and I suppose we could multiply through on both sides by 56, or something to that effect. I know it's true. I'm fairly certain that for marks, I could just say B is either A or A minus 1, but I want a slightly better justification. I'll leave it and come back to it at the end, I think. Or I'll forget about it and somebody in the comments will remind me. But let's continue on. I'll leave a space. So B is A or A minus 1. Okay. If B is equal to A, then 6A minus 7A is less than or equal to 0. And therefore K is less than or equal to 0. So N is less than or equal to 56. But we've already seen n is 239, it was 39, right? 239 is better. So we know there's something better out there, so the largest k can't be, the largest n can't be less than 56. We already know 239 is better. So then you're going to have to be looking at a situation where b is a minus 1, which is exactly how we found 239. So k will need to be less than or equal to 6a minus 7a minus 1, which will be 7 minus a. So, what can we say? At least, or maybe a is less than or equal to 0. Therefore, k is at most 7. At most 7. And so a will actually be equal to 0. And therefore, b is a minus 1, which is negative 1. Well, that doesn't work. So, then we need a to be at least 1. And that makes k less than or equal to 6. A would have to be 1, and b would have to be 0. Okay? So, but I think that's doable. So the largest n is going to look like 6k plus r, where r gives a is 1, b is 0. Now, when does that happen? So a is 1, happens down here. B is 0, happens here. The only overlap there is with 7. So this occurs only when r is 7. So the largest n is 56 times 6 plus 7. So that'll be 36, carry the 3, 33, and then we add 7, and then we get 343. And we know why this will work. Okay, so that's my final answer. Now, I don't think it's required to prove this. I'd say it's clear from the chart. If I had to actually write it down, because off the top of my head I'm not thinking of a good way to show it, but if you had time at the end you might want to come back, and I've left a little space to do so. I'm just trying to think of how. I suppose, since I can't think of anything, it might just be easier to make a big chart. So, forget all this work. Just, make big chart. Combine the two earlier ones. So, R in what ranges? I'm going to need a better chart than this. We'll get A, and we'll get B. So, from 0 to 6, they're both zeros. Just at 7, you can get A is 1 and B is 0. From 8 to 13, you'll get 1 and 1. And then from 14 to something, you'll get A is 2 and B is 1. So where does B turn over to 2? 15. So from 14 to 15, you'll get B is 1. And then starting at 16, B is 2 and A is 2, and that goes all the way up until A is 3. When does A hit 3? At 21. So, I have to... probably have to continue this over on the other side here. But this way we can sort of see. And if I do find a difference of 2, which I'm fairly confident I won't, then we can add that in. So B will be 2 up until when? Well, B hits 3 when we hit 24. So 23. And that goes up until A hits 4. And B will still be 3. All the way up until when B hits 4, and that happens at 32. And we go up until A hits 5. When does A hit 5? At 35. And then we go until B hits 5. When does B hit 5? At 40. And we go till A hits 6. So you get 7 times 6, 42. And B will still be 5. And then B will hit 6 at some point. So when does B hit 6? 48. And then A will hit 7 at 49. And then B will still be 6. And then we'll get a 7. And B will never be 7 because that would mean that we hit 56. So, that goes all the way up to 55. And there we go. And so the difference really never is more than 1. And we probably could have used this chart a little faster to make some of these other results. So maybe I should have made this combined chart earlier. But we still got our final answer of 343. Wasn't too bad. Of course, I didn't quite have the right formula, and thankfully I stopped to double check my A's and my ANs and my BNs when I was computing my answer to A, just so that I really made sure that I understood the inequality. And I did have it slightly wrong, but that's okay. We learned. And we've got space now for C4, which will be the last question. So thank you for joining me. I'll see you for C4 in the next video.